Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Alright, step on inside, and this video might run a little out of sequence from some other things you've seen before, because I'm working with another class on solving linear systems of equations, specifically involving word problems here. Now, the reason why this is out of sequence is because I attached them old videos previously, but I think I've used up and exhausted all my resources when it comes to what we did for practice assessments and things like that. So I kind of made a new one for them, if you will. And there's actually even a typo that I'm going to have to address. Hopefully in the description section, when I provide you the PDF, it'll be all fixed for you. And I'll make sure to do it as soon as we run into the problem. Only 5 problems to do, but in all 5 problems, you have to kind of take care of everything. Where I think, except for the last problem, where you define variables, you set up the system of equations, and you do solve. You address exactly what it is that's being asked. And not all these problems are, I'm not going to say they're hard, but they're not as easy as what they're going to be expected to be examined on sometimes, all depending on the nature of the situation. All of them change. So let's go ahead and get started with this. Now, these are linear systems of equations. So when you're setting these up, you're expecting one of 2 forms to really appear in each problem type. There's a... Well, let's see. There could kind of be a third, yes and no. There's the slope-intercept form, y equals mx plus b. And when I say like a third, there could be 2 different versions of a y equals mx plus b slope-intercept form. One is the one that you kind of expect, which is actually from problem number 1 that we're going to see, where you have maybe a rate and a starting value applied. But there will be another kind, and I don't know if I can call it slope-intercept form, but where you have a variable isolated and say that this person's thing is this much more or this much less or double or half or whatever this other person or this other item. Like if you win this many more games than this person, if you grow this times as fast as whatever, when you compare 2 things. So that kind of equation can show up as well. But there's another kind of equation that we're going to see. So this kind of equation, when you solve, will generally solve using substitution, where a variable is already isolated, and if we have another y equals mx plus b right here, where we can then do some form of substitution into there for a y, something like that. There's a second kind of equation that we're going to be running into, which is your standard form variety, ax plus by equals c, and then when you line it up to another one there, you're using probably the elimination method more often than not. And this will come into play when you have 2 things that kind of work together to achieve a common goal, if you will, that they line up with the same units and you can make equations as they agree together. And really one of the most important things I'm going to have to do in this video is trying to differentiate between what kinds of equations you have and what you're going to be using for them. Because I can see when you can try and make one versus another, but the question is, what kinds of equations are you going to make, and what does that equation say about what you're trying to make? And it's one thing if you already wrote the problem and you're kind of aware, but the problems really do come in one version of the or the other. You can't really make 2. You can't really make another version of it. When you make an equation, it says something, and what does it say? That's why it's important that I'm having them define variables here. So here's number 1, and I'm Mr. Robinson, so let's start this thing off. Mr. Robinson competed against world champion Joey Chestnut in a hot dog eating contest. Oh, that's very much true. Oh, you know us. In which Joey gave Mr. Robinson a 32 hot dog head start. All right, that's nice. Mr. Robinson can only eat 1 hot dog per minute, assuming he keeps that rate. But Joey eats 5 hot dogs per minute, which is probably pretty close to accurate. After how many minutes will Joey and Mr. Robinson have eaten the same amount of hot dogs? Now, this is assuming I've already eaten 32 hot dogs or that you're counting. I don't even have to have eaten the 32 hot dogs. Just pretend like that was my score. That I've eaten 32 hot dogs when he starts his go. Right? Whether I've actually eaten them or not is one thing, or if I keep that pace is one thing. The point is, when he starts, I've been assumed to have eaten 32. So after how many minutes will Joey and Mr. Robinson have eaten the same amount of hot dogs? Define variables, set up a system of equations, and solve. Okay, you can think of, so we have to define variables, and that's really what they're starting thing, right? Now, 2 variables in this system of equations. One set of things that you might think that we're saying is, and I'm going to use x and y a lot more. I'm not going to try and use b and c and things like that if they start with it. I'll try and just say x and y. Some people might say, hey, let's let x equal the number of hot dogs I eat. Hot dogs, and I'm going to erase this. Hot dogs Mr. Robinson eats. And then y hot dogs Joey eats. Now, this doesn't really work, so to speak. It can, But my question would be, what kind of equations would you work off this? There isn't a single bit of information here that says what we combine to eat together. There isn't one that says that when you take the value of something with the hot dogs per minute, there's a whole other variable that we're not talking about right here that's really important, and it's time. And that's one of those things that you have to consider is what information, it's not what information don't we know, it's what information do we need? What information are they asking us for? And yeah, there's something about us with hot dogs, but the amount of hot dogs we eat don't have any information to say what they combine to. They don't value to something together as in, and we make this much money or spend this much money on each hot dogs that we eat, and it combines. There's nothing like that. What it says is the number of hot dogs we eat is dependent on the amount of time that has occurred. So, excuse me, this isn't the thing itself. And furthermore, we're not going to define variables that differentiate between how I eat hot dogs and how he does. There will be two equations that do, but not variables. So the amount of hot dogs we eat is dependent on the amount of time that has elapsed. So time is an important thing here, and that's generally an x. That's generally an independent variable. Remember, it's dependent on time. So we're going to let x equal the number of minutes that have gone by. Since Joey's eating his hot dogs technically because of my 32 hot dog head start, but number of minutes eating, competing, eating hot dogs. We don't compete till Joey starts. I'm just going to say number of minutes competing, whatever. Why is the number of hot dogs eaten? Now this is for each individual because the thing is we still have to make equations here. Hot dogs eaten, really per contestant, right? But what we're going to do is we're going to make two equations. There's going to be an equation for Mr. Robinson. I'm just going to put Mr. R. And there's an equation for Mr. Chestnut, for Joey. Based on the number of hot dogs we eat. We both have our own separate y's. And that's the thing. We don't have to have separate variables. Our y's dependent on different x's. These are different equations that work in the same system. We have to find out when will our y's be the same. And that's really how this question works out. I'm trying to figure out the same thing. For what x do we have the same y? And a lot of these things all fall together to know that this is a y equals mx plus b kind of equation, especially including where they give us rates. I only eat one hot dog per minute, so I have a rate and a starting value. Joey Chestnut has a rate, and his starting value, he starts at 0 hot dogs. So all of that together tells us that this is a slope-intercept form kind of equation. My equation is the number of hot dogs I eat is this. I've started with 32 hot dogs, which means even when the bell dings and Joey hasn't eaten a single hot dog, however it is I've consumed these or it's counted as 32, I have 32 hot dogs eaten, period. Now, every minute that goes by since then that Joey starts competing with me, I eat one hot dog per minute. So if I eat one hot dog per minute, I multiply one hot dog per minute by the number of minutes that have gone by. This way, when 10 minutes go by, I will have eaten 10 hot dogs since the bell and 42 hot dogs total. We can make a table out of this and make sense of it, and you totally would as well. But we're making the equation out of it as well. Do I need the 1? No, I can erase that, and 1x is the same thing as x. Y equals x plus 32. There's an equation for me. Y equals mx plus b. Joey's equation's kind of similar, but see, when he starts, he hasn't eaten any hot dogs yet. So at time 0, he's eaten 0. If you put a plus 0 there to initiate it, that's fine. I'm going to erase this eventually. But he eats 5 hot dogs a minute. And when you multiply that by the number of minutes, you can get how many hot dogs he's consumed after those minutes. After 3 minutes have gone by, he's eaten 15 hot dogs total. He started at 0. 3 minutes gone by, 5, 10, 15. So that plus 0 really need not be there, just like the 1 for me need not be there. So I have two equations, one for Joey, one for myself, the number of hot dogs we eat based on the number of minutes that have gone by, assuming I have the 32 hot dog head start. That's our system. That's our system. Now, they're asking, after how many minutes will Joey and Mr. Robinson have eaten the same amount of hot dogs? So we're trying to solve for x. How many minutes have gone by here? So I'm going to solve the system. Let me state this. Some of my students looked at this at the bottom, 50 hot dogs, Mr. Robinson win, and they're trying to make an equation out of something with 50. We haven't looked at this. This doesn't exist yet. This question doesn't even pop up. It is irrelevant to the situation. Just bye. It's not there. We're not talking about it. So ignore that completely. Don't look ahead for something like that. But let's go ahead and solve this thing. And I'm going to solve using substitution. I understand that elimination is a facet we can use, but I'm going to use substitution. I have y equals something. I have y by itself in both equations. If y equals this and y equals that, I want to find out when this equals that. I'm going to substitute 5x for y. It will replace y because you know why? It equals y. It is equivalent to y. The thing, I never used this in a video yet, so I'm going to use it now because I used it with my students before. Let's say that you are at a restaurant and there's a specific menu item. It's a combo plate, and it comes with, let's say you have your main course meal, and it comes with the sides and whatever else. Let's make it up. Let's do this together before I continue this, because some students have trouble with substitution in why 5x is replacing y. Let me first actually write this equation out. 5x equals x plus 32 is the new equation I'm writing. Let's say that I have a meal where I order chicken, and with that chicken comes rice, beans, and a soda. And I say, and this is the number 4 on the menu. And I have the menu thing, and they're like, what would you like to order, sir? And I say, can I have the number 4? So when they hear number 4, they're like, this is what's in number 4. I can't have the number 4. I'm like, okay, sure. And I'm like, okay. But instead of beans, can I have cauliflower? Okay, now you guys tell me, and now say they say, sure, coming right up, same price. Let's say that you can substitute another vegetable, but this was called chicken and beans as a menu item. You're like, can I have the chicken and beans? Can I have number 4, but instead of beans, can I have cauliflower? They say, coming right up, they make the order, we eat, we pay. Now you tell me, what is in this order? If beans equals cauliflower when it comes to what I can substitute, how do you spell cauliflower? Is it just W-E-R? I don't even know. I probably should have used something else. I don't know how to spell broccoli though either. Is it 2 C's, 2 L's, whatever? All right. So if beans equals cauliflower, and this is my order, what will my new order look like? It will have chicken, rice, cauliflower, if this is how you spell it, whoops, California. It'll have cauliflower, I don't know if that's how you spell it, and soda. Why? Because I substituted that, because they were equivalent, price, cost, whatever it was. One substituted for the other, and everything else was the same. I know I'm spending a long time talking about something with substitution that's going to be a little foreign, but this is more for my students than anyone else, those who have trouble with it. 5x took y's place. I'm saying, can I have the y equals x plus 32 meal? But instead of y, can I have 5x? They're like, well, they are equal, so yeah, it can go ahead and take its place. So what will my menu order item be? It'll be 5x equals x plus 32. Not y equals x plus 32, but 5x equals x plus 32. And that's a simple substitution. That's one without needing distribution in parentheses and all that. That's a simple one. We might potentially get another one after that. All right, I'm not spending other time on talking about substitution like that. I really wanted to hit that home, though. I sure hope that was an entertaining talk. So, solving for x. This is the solving, I'm going straight into it, guys. Subtracting x from both sides. 4x equals 32. Dividing both sides by 4, we're going to get x equals 8. Now, the question being asked was, after how many minutes will Joey and Mr. Robinson have eaten the same amount of hot dogs? We have to answer that in words. After 8 minutes. 8 is number of minutes, right? After 8 minutes. Joe's hot dogs. Joey and Mr. Robinson. Now, you might want to check and see if you did the math right for that and check and see how many hot dogs it was. But Joey and Mr. Robinson will have eaten. By the way, you're going to have a weird abrupt pause in this thing. You might not know or care, but I need to respond to something. It's going to take a little while, probably 20 minutes or so. So after I finish this problem number 1, I'm going to pause it, come back, whatever. Joey and Mr. Robinson will have eaten the same amount of hot dogs. Now, what is that number? Let's check that, and let's make sure we did it correctly. How do we check? We'll figure out how many hot dogs will have Joey eaten after 8 minutes. If he eats 5 hot dogs a minute, 5 times 8 is 40. You can check, you can substitute, right? That's how we solve a system of equations. Y equals 5 times 8, that equals 40. Would Mr. Robinson have eaten 40 hot dogs after 8 minutes? Assuming he's already eaten 32 to start. 32 plus 8, right? 1 hot dog a minute. 8 minutes have gone by. So Y is 8 plus 32, which is 40. So there's that tangibility there. Having the word problems really makes sense of what it is that's happening in the answer. And yeah, we each ate 40 hot dogs at that time. All right, now the next question comes into play. If the first contestant to eat 50 hot dogs is the winner, will Mr. Robinson win? Now, there are a couple ways you can do this, but the main point that I wanted to make here, I really should have said explain, show, or something like that. But here's the thing. Joey eats at a faster rate than I do, and Joey matches me before 50 hot dogs have been reached. If we saw this on a graph, it would probably make a little bit more sense. But once Joey matches me, he will then thereafter pass me. Another minute later, at 9 minutes, Joey will have eaten 45, and I will have only eaten 41, because I'm only going to eat one more hot dog after that. He'll have eaten 45. Once Joey matches me, and 50 hot dogs haven't yet been reached, he'll match and pass. It'll go like, here's my rate, here's his rate, and he will just go past me. It's like he's running past me. I'm running a certain speed. I'm ahead of him. I need to reach the finish line. I'm not there yet. He's running at some speed faster than me. He meets me. We're tied. He passes me. He's gone. Will Mr. Robinson win? Hell no. No. By the time Joey will have and listen, there are a lot of other ways you can do this. What else can we do here? Check this out. I was just saying no just by logic of what I talked about. At 8 minutes, neither of us have gotten to 50. What else could we figure out? At 50, how long will it take? We can do that. I can say for Mr. Robinson's equation, to reach 50 hot dogs, y being 50, if y is 50, how many minutes will it take him? X would have to equal 18. It'll take me 18 minutes to get to 50 hot dogs with a 32 hot dog head start. How about Joey? 50 equals y, what am I doing? 50 equals 5x. You divide both sides by 5, you'll get x equals 10. It'll take Joey 10 minutes. He'll beat me and then some. It's not gonna be close at that point. That's why he's giving me such a nice head start, and even then, that's it, man. That's it. All right, I'll come back, and by the way, this 36 is what needs to turn into a 39 there, but I'll come back after this, and see you then. Okay, and we are back. All right, here we go. So, finish number 1. Number 2. The Rio Americano Raiders took on the El Camino Eagles. These are our schools. El Camino Eagles football team and won 54-39. Changing that to a 9. If yours isn't changed in any sort of PDF or thing you want to do, change it from 36 to a 39, please. The Raiders scored a total of 10 times with a combination of touchdowns and field goals. Each touchdown is 6 points each with an extra point. Let's assume they make their extra points. Touchdowns and field goals. Touchdowns are 7 points. Field goals are 3 points each. How many touchdowns did the Raiders score altogether? Set up a system and solve clearly defined variables. Now I'm going to do X as number. Listen, they only ask how many touchdowns did the Raiders score altogether. That's not to say they couldn't ask how many field goals did the Raiders score altogether as well, which is the other unknown in this scenario. We know how much they're valued at, but we don't know how many of each they scored. And we know how many total they scored. We don't know how many of each they scored. So I still need to define variables for number of touchdowns and number of field goals together. So I'm going to go ahead and let X, and again, I'm just going to keep doing X and Y for these ones. Let X be number of touchdowns scored. Now, there's a second question down below that have to do with the Eagles, not the Raiders. I'm going to keep the same variables. In fact, it says use the same variables as above. And Y equal number of field goals scored. And see, keep in mind. See, hold on. Scored. Oops. Keep in mind here. I'm using same variables, and it'll be for a completely different system and different information for later here. But X and Y, Eagles and Raiders are both sharing the same variables for number of touchdowns, number of field goals. That doesn't mean they scored the same amount. right? That doesn't mean they score the same number of and things like that. They're valued at the same thing here, but that doesn't mean they score the same amount. So same thing with the hot dogs thing. If you say X's number of hot dogs, Mr. Robinson ate, Y's number of hot dogs, Joe ate. No. You can use the same variables for them and have different equations or systems and stuff represent their specific Y and number of hot dogs. Same with this. Their specific number of touchdowns and field goals. This isn't a rate that they scored a certain number of touchdowns a minute, per quarter, per minute, anything like that. There's a combination here. They scored a total of 10 times with a combination of this. You're going to combine number of touchdowns and field goals. You're going to combine number of points from touchdowns and field goals. This is very much one of those, what are they called? Standard form sets of equations where we should probably solve using elimination here. Let's look at two different equations that we're going to be setting up here based on this scenario. First one is the Raiders scored a total of 10 times. A total of 10 times there. Now, the 10 times means if I scored a touchdown, I scored one time. If I kicked a field goal, I scored a second time. If I kicked another field goal, I scored a third time. So you're combining your scores. No safeties. The extra points are counted in the touchdowns. We're stating how many touchdowns, we're stating you scored 10 total touchdowns and field goals. Not 10 touchdowns and 10 field goals, but a total of 10 touchdowns and field goals. So the number of, which is unknown, the number of touchdowns that I've scored, the Raiders scored, plus the number of field goals the Raiders have scored equals 10 total times scored. This does not mean 10 points. And furthermore, we would not add our X and Y number of times scored for touchdowns to match the number of points we scored, just the number of times we scored. This is a number of times scored equation. We are going to make another equation, though, based on the score that we've made. And by the way, if the Raiders beat the Eagles, and this is a Raiders scenario, then the Raiders scored the more points. The Raiders scored 54. So we are going to make another equation that says something that equals 54 total points scored. Now, do I just say X plus Y equals 50, touchdowns plus field goals equals 54? No, because X isn't points scored from touchdowns, it's number of touchdowns scored. If you want to find the value of all the points you scored from touchdowns, you got to multiply the number of touchdowns you scored by 7. Because I don't know the answer to this to my own question here. Let's say you scored 2 touchdowns. How many points did you score in those 2 touchdowns? You multiply 7 by 2. The amount of points you scored per touchdown by the number of touchdowns. We don't know how many touchdowns we scored, so we multiply 7 by that unknown X. This is 7X. This is the number of points scored from touchdowns. Number of points scored from field goals isn't just Y. This is how many field goals you scored. But if you multiply 3 points per field goal scored by the number of field goals scored, you get how many points you scored from field goals. So this equation states the number of points scored from touchdowns plus the number of points scored from field goals equals 54 total points scored. And that is your system of equations. Alongside this one, it says number of touchdowns scored plus number of field goals scored equals 10 total times scored. So that's your system. Excuse me. Now solving this thing is through elimination. And I'm not going to speak too large on this thing here. If I add down these lists right now, no variable eliminates. But if I turn this y somehow into, say, a negative 3y, and I can't just turn it into it, but if I turned it into a negative 3y, negative 3y plus 3y would sure be 0. If I turn this into a negative 7x somehow, negative 7x plus 7x is 0. And I can do that as long as I multiply both sides of this equation, excuse me, by something to keep balance. I'm going to do the negative 3 because it's a smaller number and it keeps other terms positive after adding. So if I multiply this by negative 3, it's going to distribute. In a rewrite of this equation, it'll now say negative 3x minus 3y equals negative 30. Make sure you multiply everything there. Now I'm going to add this equation with this equation straight up, line up the x's, y's, equals, and constants, add things up. Don't miss adding anything. 7x plus negative 3x, we get, where's my pen I used? 4x. 3y minus 3y is 0. That's the goal. We wanted to eliminate, get one variable in one equation. And 54 minus 30 is, oh, hang on, something just happened to my thing. Uh-oh. There it is. 54 minus 30 is 24. So 4x equals 24. Divide both sides by 4. We get x equals 6. Now, the question ultimately was how many touchdowns did the Raiders score altogether, and x is the number of touchdowns scored. I actually do answer my question during that. You know what? I really should have, I didn't even look at that. If I eliminated x's to solve for y, I would have found how many field goals I scored, and that wouldn't answer the question being asked. That's not to say you can't find out how many field goals scored, but this is an absolute must. So the Raiders scored 6 touchdowns. That's an impressive game. The Raiders, 54 points is impressive. The Raiders scored 6 touchdowns. Now, if you're curious how many field goals they would have scored, let's forget algebra, put it into perspective. If you scored 10 times total and you scored 6 touchdowns, how many field goals did you score? You all know that. It's 4. How'd you get it? Well, it's because 6 plus 4 is 10. 10 minus 6. Where do you do 10 minus 6? Well, now let's look at the algebra. In this equation up here, x plus y equals 10, if I substitute 6 for x, I will get an equation that now says 6 plus y equals 10. And subtract 6 from both sides. That's where you subtract 6. You get y equals 4. They scored 4 field goals. So let's see if this does work to confirm it, and then we'll move on to the next part. 6 touchdowns scored means 6 times 7 is 42 points scored from touchdowns and extra points. 42 points scored from touchdowns. 4 field goals, 4 times 3 is 12, means 12 points scored from field goals. So how many points were scored total? 42 plus 12 is 54. And that is how those things work. You use more real numbers. You try and think about the problem, speak about it out loud, what units are using. You will not miss. And furthermore, you'll understand why this kind of equation setup is used in standard form as opposed to some slope-intercept form thing. All right, there's a second question involved here. The Eagles, the other team, also scored via touchdowns and field goals. So they had a combination of those. The number of field goals they scored was twice the number of touchdowns they scored. How many field goals did the Eagles score? Now it's number of field goals. We'll remember that. Setup, system, solve. Let's use the same variables as above. X is number of touchdowns. Y is number of field goals. All right, it sounds like they only gave us one bit of information, though. We scored touchdowns and field goals. They didn't say how many they combined to be, though. Can't assume it's 10 times. In fact, they only scored 39 points. Can't assume it's 10 times. But you heard what I just said. They scored 39 points. That is a bit of information that we can use. We have to go back to the top here. Not 36, but 39. They snuck in another field goal, if you will. 39 points scored. We can use the same exact setup that I did right here. 7x plus 3y equals 54. Do the same exact thing for the Eagles, only instead of equals 54, we can say 39. Because this says the points they scored from touchdowns plus the points they scored from field goals equals 39 points scored. There's going to be a different XY answer to this thing. This is an Eagles equation. It's a different system. But it's the same thing that's going on. Same value assigned to touchdowns and field goals. It's not like when you have a different question regarding quarters and nickels, which is not on this question set, by the way. It's not like the quarter value changes, and just the amount of money you have in total changes. All right, now there is another bit of information that is right here. The number of field goals they scored was twice the number of touchdowns they scored. Now, this is one of those examples of an equation where you're not adding one thing to another to equal something. We don't have information that says that. This is a comparison of two things. This is a comparison of the number of field goals you scored and the number of touchdowns you scored. Now, I'm stating y equals x as a precursor for what we're doing here. Does y equal x? Did the Eagles kick as many field goals as they scored touchdowns? That's my question to you. Your answer is no. They scored twice as many field goals. Not that they had twice as many points from field goals. That would be a mistake to think about it that way. They don't have twice as many points from field goals. They kicked twice as many field goals as the number of touchdowns they scored. So we're comparing y to x. Does y equal x? No. What do you have to do from one to match the other? Well, let's think about it in a just a made-up scenario. If they scored 5 touchdowns, how many field goals would have they kicked? If they scored 5 touchdowns, they scored twice as many field goals. You would have doubled the 5 to get the number of field goals. So what you're going to do here is you're going to say however many touchdowns they scored, double it, and that will match the number of field goals they scored. Field goals scored is twice the number of touchdowns scored. There's your setup. So this is one of those, I was stating, it's not a y equals mx plus b. I mean, it kind of is. But it is a variables isolated to get a comparison between one thing and the other. And that's not quite standard form. We're not calling it slope-intercept form because it's not really, it's kind of a rate. It's twice as many. But, yeah, it's kind of a rate. But it's not the same way as slope-intercept form as initial amount, whatever. It is a comparison between one of your instances and the other. So that is your system of equations here, and this is where we get to now play substitution again. I opt to use substitution here because x is on a different side of the equation as y is by itself and isolated. Can I get the number 4 with chicken, rice, beans and soda, but can I substitute, instead of beans here, can I substitute cauliflower? 2x can take y's place because 2x equals y. So let's get the same order. Let's get the chicken. Oh, let me give it a different color. Let's get the chicken. Let's get the rice. Let's get the cauliflower instead of the beans. No cauliflower, or no beans, cauliflower. And, let's get the soda. Okay, substitution. Taken care of. I use parentheses because 3y means 3 times y. If I wrote 32x, that's not the same thing as 3 times 2x, so I got to do that. All right, 3 times 2x is 6x, so 7x plus 6x equals 39. In this expression, I'm going to combine like terms. 7x plus 6x is 13x. 13x equals 39. Divide both sides by 13. You will get x equals 3. Now, they did ask how many field goals did we score. I only found out how many touchdowns thus far. That's fine. We can still solve this thing pretty handedly. Use an equation that works best for you. I like the one, not the points one. I like the one that says you scored twice as many field goals as you did touchdowns. If you scored 3 touchdowns, guess what? You scored 6 field goals. Not that you scored 6 points off field goals. The ball went through the upright 6 times for 18 points. That's a lot of field goals to be kicking. The Eagles scored 6 field goals. Now, I could be mean and I could ask how many points did they score off field goals and get that 18 points there. And that's something you'd have to notice as a question. I do sometimes ask some questions like that. So you have to make sure you answer the question being asked. Make sure you're always answering the question being asked. And that's this instance right here. I'm not going to double check that. So now one thing I want to mention is if this was 36 divided by 13 doesn't equal an integer. I think at the time I was using touchdowns as 6 points only. And then I had a different problem before I changed it. Or it was a typo. I can't remember. All right. So those are the first 2 questions there. And 30 minutes covered. Learning as you go. There's a reason I'm presenting this one to you. And here it is. All right. A farmer had chickens and pigs on his farm. One day he got extra mathy and counted a total of 26 heads and 80 legs among all chickens and pigs. How many total chickens does he have on his farm? How many pigs does he have? So we got to answer both. Make a system of equations and solve. Make sure to define variables. Hint, think about how many legs each animal type has. So in order for this to work, and again, we're making the assumption that all pigs have the same number of legs. All chickens have the same number of legs. We need to figure out how many chickens, how many pigs. Straight up, they're asking you. Those are the variables we're going to define. That's how we're going to work this thing out. So let's let x equal number of chickens on the farm. Number of chickens. I remember the first time I wrote this problem, there's an old MacDonald had a farm, and on his farm he had chickens and pigs. Y is number of pigs. Okay, now there are 2 different equations that we can make. There's one regarding the number of heads that he counts. And again, no mutation, no kind of strange, they didn't lose any heads or anything like that. The number of heads there are also the number of animals that there are. So I mean, we can have a heads equation. When I say number of pigs, it's also number of pig heads. Number of chickens, number of chicken heads, assuming they're still attached to the body. They never said these are alive, but let's speak to the larger crowd here that's going to say they're alive and they're well. So number of chickens, number of pigs is also the same as number of heads when you combine them. So when I say that you add the number of chickens and the number of pigs, you get 26 total animals. It makes sense that you're associating number of heads with number of animals. So that's an equation that we can associate there. Now, another part of this has to do with the values associated to the legs. Each chicken has 2 legs. So when you're trying to get a legs equation, 80 legs total, something is combining legs. Number of legs of all chickens, 2 legs each, blah, blah, blah. 4 legs each per pig. That doesn't mean 2 plus 4 is 80. You take 2 legs per chicken times the number of chickens, and this is all the legs that you have for all the chickens. Here are all the chicken legs total. When you combine it with all the pig legs total of 4 legs per pig times the number of pigs there are, you get all the legs from all the pigs. When you combine all the legs from chickens and all the legs from pigs, you get all the legs that there are, 80 legs total. And this can get us our system of equations. And remember, you can't answer this with just one bit of information. If I told you there are 26 chickens and pigs total, and asked how many chickens and pigs there are, It could be 0 chickens and 26 pigs. It could be 26 chickens and 0 pigs. It could be 13 and 13. The only thing we can say for sure is it should be integer, not decimal. So it's a finite answer, but given this information, it's only going to get us to one answer. If we graph these, there's a point of intersection where it finds this x and y. There's only going to be one answer to this for the 80 legs. If I do 13 and 13, you might not get 80 legs. Whereas if I do this and this, you might. So what we're going to do is we're going to solve for x and y here. You need to find both. Your choice what to do. I'm going to go and use elimination, but your choice on how you want to eliminate. Do you want to eliminate y? Do you want to eliminate x? Most people would probably say, let's eliminate x and multiply the top by -2. And I have no problem with that. I'm going to state the fact that you could take this bottom equation and we could have divided it by -2 because everything here is divisible by 2 and that would make numbers smaller. I don't think it's too bad of an issue to multiply by -2 though. I think that's what most people will see. I don't want them to make a mistake in a case that you can't. So if you multiply both sides by -2, you get -2x minus 2y equals negative, that's 52. And then when you solve this thing right there, well, let me go ahead and solve this thing. 2x minus 2x is 0x, it's 0. 4y minus 2y is 2y, and 80 minus 52 is 28. We solve for y. We get y equals 14 because we divide both sides by 2. There are apparently 14 pigs on the farm. How many chickens are there on the farm? 14 pigs is also 14 heads, whatever, blah, blah, blah. 26 heads total. That leaves room for 12 more heads, 26 minus that. So to do that work there, that would be x plus substitute. 14 equals 26. Subtract 14 from both sides. X equals 12. Now we're not done. Even in a non-contextual problem, we'd write the answer as an ordered pair. But no ordered pairs here. We are actually answering the question. The farmer has 12 chickens and 14 pigs on his farm. Be very, very specific. You are good. Okay. Now, by the way, when I stated that, some of these problems might be different compared to what I present on a test is, I'm making you do every single part, which is that's not to say you shouldn't be able to, but I'd like, for the sake of time and such on the test, and if I'm doing this, I'd like to build to it. I might say write the equation here, or I might give you the system of equations and say what does 4y represent, and what does 4y represent? The number of legs of all your pigs. All your pigs, not each pig. Four legs per pig, yeah, but there's y, which is number of pigs, number of legs of all your pigs. What does x represent? You can either say number of chickens or number of chicken heads. What does 26 represent? All the animals or all the heads. All right, number 4. Chris Hemsworth is 6 years older than his brother Liam. 30 years ago, Chris was quadruple Liam's age. What is the sum of their ages today? No looking it up. Solve this algebraically here. I had to look it up to come up with the problem. All right, and by the way, one of them, I forget which one. One of them had a birthday about 10 days ago or so, and now this is actually accurate as of January 24th. Chris Hemsworth is 6 years older than his brother Liam. So, hold on, let's define variables. What is the sum of their ages means we need to figure out what each of their ages are in order to do this. Because we don't have any other information that says when you add their ages, you get this. So there's not going to be an equation to start with in a system that says x plus y equals whatever the sum is, because we got to find it. That will be the ultimate thing we do in order to get that answer, but we don't have it now. That being said, we need to define those variables. Let's let x equal Chris Hemsworth's age. Chris Hemsworth's age. This is in years. Not in months, not in weeks, not in decades. Y is Liam Hemsworth's age. I could say Chris and Liam, whatever. Liam Hemsworth's age in years. I know for some people they're like, that's a lot of writing to be too particular. No. Be specific. Be very, very specific for yourself, for the kinds of equations that you set up, for the story that you tell, for the answers that you do. Be very, very specific. There is no overkill for that. None. All right, Chris Hemsworth is 6 years older than his brother Liam today. So we are comparing. We're comparing. Is Chris's age equal to Liam's age? Well, no. How do I make them equal? If you take Chris's age, let's say I don't want to give away the answer. Let's just make them old. Let's say Chris is 50 years old, and if he is 50 years older than Liam, then Liam must be 44 years old. You would subtract 6 from Chris's age to match Liam's age, or you can say you would add 6 to Liam's age to match Chris's age. Either way, you can either write this one of two ways. You can either write x minus 6 equals y, totally fine. But since we're saying older, I like to think of the whole add to, not that it's x plus 6, but that it's y plus 6. Whatever Liam's age is, add 6 to it, you'll get Chris's age. There's an equation. Comparison between the two. This part's a little harder. This isn't something that my students have really run into, so this is going to be a little different. 30 years ago, Chris was quadruple Liam's age. Now, the quadruple part means 4 times the age. So let's state for a moment, this isn't quite correct, but let's state for a moment that they said, let's say that Chris's age 30 years ago was x, and Liam's age 30 years ago was y. We can do the same thing. We're comparing again. Does x equal y? No. But Chris was quadruple Liam's age, meaning if you take Liam's age and multiply it by 4, you would get Chris's age. So this is kind of what we're going to do. We're going to say, take Chris's age 30 years ago, take Liam's age 30 years ago, and multiply it by 4, and whatever. You'll match them. The thing is, Chris's age 30 years ago wasn't x. If Chris is 50 years old now, which he's not, if Chris is 50 years old right now, how old was he 30 years ago? I don't care about the number. I care about what you would do to get it. If Chris is 50 years old now, you subtract 30 years to get how much he was 30 years ago. If Liam is y years old right now, you would subtract 30 to get Liam's age 30 years ago. So, if Chris is x years old right now, Chris's age 30 years ago is x minus 30. Take his age now and subtract 30. So, what we're going to do is we're going to write an equation that uses Chris's age 30 years ago and Liam's age 30 years ago. Now, are their ages the same when they were 30 years ago? No, Chris was quadruple Liam's age. That's where we multiply by 4. There's still an error. I don't just multiply. It's not quadruple Liam's age and then subtract 30 years. It's called quadruple Liam's age 30 years ago. So when I say quadruple Liam's age, I mean when they were both 30 years ago. So you have to subtract 30 first, right? The y minus 30 has to happen first. You have to take his age, subtract 30 from it, and then it's his age, and then quadruple it. So parentheses. That, folks, is how we're going to set this thing up. That is our system of equations right there. Pretty different, that's really thinking that thing out, but if you listen to it, it makes sense. Okay, even though there are things I can do to clean this thing up, I'm going to jump into straight substitution now, and then we'll clean up as we go. But I totally want to go substitution on this right here. So I have a variable by itself right here in x. Without doing any other cleanup here, without touching it yet, I'm just going to go straight substitution. If x equals y plus 6, then y plus 6 can take x's place. Instead of x minus 30, I can write an equation that'll say y plus 6 minus 30. So y plus 6, taking x's place, minus 30, equals 4 times y minus 30. Kind of a weird looking equation as far as this stuff goes, but if I say solve for y, let's do it. 6 minus 30 is negative 24, so y minus 24. And I got to start solving for y here. I'm going to go ahead and distribute this thing now. 4y minus 30 right there, and we get, 4 times y minus 30 is 4y minus 120. Now I got to start solving for y here. I like to keep my variables positive whenever possible, so I'm going to subtract y from both sides. So I get 3y. And if I'm getting y by itself on one side of the equation, I'm going to go ahead and add 120 to both sides over here. So plus 120, negative 24 plus 120, that's 96. Divide both sides by 3. 96 divided by 3 is 32. We get y equals 32. Today, Liam Hemsworth's age is 32 years old. He's 32 years old. How old is Chris Hemsworth today? You can either go to the bottom equation and compare how they were 30 years ago, or you can go to the top one. Chris is 6 years older than Liam. You take x equals, where's my color? You take x equals 32 plus 6. and x is 38. Today, Chris Hemsworth, I'll say Chris is 38 years old today, and Liam, that just glitched, and Liam is 32 years old. Now, does this apply? I mean, look, that's the answer, and we set up the equations to work, but does it work with the 30 years ago scenario? 30 years ago, how old were they? 30 years ago, Chris was 8 years old. 30 years ago, Liam was 2 years old.
I'm going to be a good actor.
Are they British? Are they British? I can't shoot. Liam's a very British name, right? I don't know. I know he plays Thor and all that. Yes, right? He's British. Anyway. What was I saying? Oh, 8 and 2. 8 and 2 years old. Is 8 quadruple 2? Yeah, 2 times 4 is 8. That works out. All right, last problem here, number 5. I'm spending a lot of time in the conversational pieces, plus the whole British stuff. But the conversational piece is how you make sense of this stuff. You have to have an inner dialogue for these problems to make sense of what it is you're doing. Okay, you collect $900 in donations to purchase jeans and hoodies for a children's charity. A local store sells jeans for $20 each and hoodies for $30 each. You want to purchase at least 35 articles of clothing. So you can buy all 35 hoodies. Well, if you can afford it, you can buy all 35 hoodies if you wanted, or versus 20 or no jeans or more. You want to purchase at least. You could buy 50 of something like that. If you can afford it, you want to purchase at least. So what we're going to figure out, this is a system of inequalities, not a system of equations. We're going to be a within here. You don't have to purchase exactly $35 of clothing. You don't have to spend exactly $900. And I should have mentioned that. $900 is the most that you can spend. I hope that kind of makes sense. When I say at least here, the understanding is, well, I guess if they donate it, then you are spending all $900. I guess that's argumentative, but you'll give back. You'll say, all right, thank you. Here's reimbursements, or you pocket it yourself. Let's not go in that form. All right, this time I define the variables for you just to get things started. Let x equal number of jeans purchased. Let y equal number of hoodies purchased. Honestly, main reason why I wanted to do this is because we're going to graph it, and because we're going to graph it, I wanted to make sure all graphs align to be the same way. If you swap x and y, then you have a different y-intercept and things like that when you graph them. All right, set up a system of inequalities. The fact I state inequalities kind of lets us know we can't spend more than 900, and I want an inequality, so we'll talk about the situation, then graph the system. So we already have x and y defined. We do know, let's do the easy one first. You want to purchase at least 35 articles of clothing. We want to make sure that when we combine the number of jeans we purchase and the number of hoodies we purchase, that it matches at least 35, or you can spend more. See, 35 is what we are comparing how much you buy. You buy X amount of jeans, Y amount of hoodies, and you need that to exceed or meet 35, so greater than or equal to. That is one inequality. The second inequality has to do with how much we spend, and we've kind of talked about a couple of these now. Not as money, but here we go. You spend $20 per pair of jeans. You multiply that by the number of jeans you purchase. This is how much money you spent on jeans. You spend $30 per hoodie. I was going to say pair of hoodies. Per hoodie. You multiply that by the number of hoodies. That's how much money you spend on hoodies. When you combine these, this is how much money you've spent altogether. The amount of money we spent altogether may be $900, but it cannot exceed. We're going to allow less. For the sake of this inequality, less than or equal to works out. This is our system of inequalities. Now, we need to graph the system of inequalities here. And, I preach slope-intercept form a lot for my students as far as a rewrite goes, like y equals mx plus b, or in this case, y is greater than or equal to, if I subtract x over, mx plus b. So we can graph that one. In this case here, it would probably be a two-step process. I got to subtract 20x and then divide by 30. So if I subtract 20x from both sides, I get 30y is less than or equal to negative 20x plus 900. If I divide everything by 30 right here, I'm going to get y is less than or equal to, no inequality flip, you didn't divide by negative. Negative 20 divided by 30 is also negative 2 divided by 3, negative 2/3. Negative 2/3 x plus, and 900 divided by 30 is 30, so plus 30 like that. So here's slope-intercept form versions of these. Now, I could have used standard form, and by and large, you actually would have landed on integer intercepts, but you then have to make sure that your greater thans and less thans work as far as shading goes. If your y is by itself on one side and y is greater than, we will shade above. If y is by itself and y is less than, we will shade below. So this one, you know when it's by itself what happens. We get to work off slopes. I'm fine here. If you want to work it in standard form, you totally can. See what you get. So in zooming out here. So I'm going to graph these. I'll keep them the same color because you got to use pencil. You probably got to use the same color here. Negative x plus 35. We started a y-intercept of 35. I'm going to begin here. Now my slope is negative 1. That means negative 1 over 1. So we go down 1 over 1 like this and down 1 over 1. Now you might say, whoa, Mr. Robinson, if you look at the scales go by 5. You're not going down 1 over 1. You're going down 5 over 5. And you'd be right. I am. I'm going down 5 over 5. But isn't 5 over 5 the same thing as 1? Isn't negative 5 divided by 5 the same thing as negative 1? Yeah, it is. And so the moral of that story is as long as these scales are the same, as in going by 5s, then I can treat this as down 1 over 1. I don't literally have to go to 34 and 33 and, things like that, as long as it maintains. Because eventually I will get to this point. Our goal here is to make the most accurate looking graph possible and with the least amount of headache. So what I'm doing right here is just keeping it all within the family like that as I do this. I'm going to include arrows on this because I'm drawing the graph of it, but keep in mind, we are kind of restricted to the positive realms of, sometimes I state that x has to be greater than or equal to 0, y has to be greater than or equal to 0. We're not going to graph negatives for these. Anyway, I am doing a solid line here, solid because it's also equal to, and the shading is the greater than. I will be shading above this line here. So I'm making a first quadrant graph. We will be shading above. Let's go ahead and make that look, like this right here. Okay. Now, what you're looking at is a scenario. The shaded region represents solutions to the single inequality x plus y is greater than or equal to 35, as to state that anything within shaded region or on the solid line states that as long as I purchase that number of jeans and that number of hoodies, I will have gotten at least my 35 or more. But like this point right here states I bought 15 jeans and 45 hoodies. That's a total of 60 articles of clothing. That would satisfy me wanting to purchase at least 35 articles of clothing. Can I afford that? Well, that's what the other graph is for. Y is less than or equal to negative 2/3 x plus 30. So this graph, I said I'd use the same color. So this graph here, plus 30 is that y-intercept. Now, again, the scaling, I can go down 2 over 3 like this, or down 20 over 30, whatever. But down 2 over 1, 2, 3, there's a point. Down 2 over 1, 2, 3, and down 2 over 3. That's kind of enough for me there. I'm going to go ahead and draw that. The solid line, once again, we can include those points. And this one I'll be shading below this line. Now, you want to be careful when I say shade below. Some people start to look at the other line and say like, okay, this is a part of what I need to shade below. No, you're only looking, maybe I should color code, but we're only looking at this line. Please ignore everything else in this graph, but this line you see right here when you shade below. So as I shade below here, I need to go back to that same thickness and shading. When I shade below here, I'm going to shade below this line right here. See where I'm shading right here? I'm shading below this line right there and right here as well. Now this isn't going to be perfect as far as what I'm trying to get in, so I'm going to really show the overlapping shaded region. But I'm shading below this line only and exclusively. That includes this. This is below the line right there. There we go. Okay, not perfect, but what do we see here? What we see is an overlapping shaded region. And that is right here. This shaded region is above the first line, below the second line. This region is the set where you can have solutions. You can have solutions to this thing, that you bought at least 35 articles of clothing. By the way, the solid lines count. Being on the solid lines count. That you bought at least 35 articles of clothing, and you spent, you were within your budget of $900 or less. Because all this, right, if I buy 0 articles of clothing, 0 jeans, 0 hoodies, I didn't spend my $900. I'm satisfied with one part, but not with the other. I needed 35. So it needs to be anywhere in this region right here. You'll be good. That does mean you could buy 40 jeans and 0 hoodies, and you've met your 2 requirements there. You're trying to not feed the children. You're trying to clothe the children. You're trying to make sure that you get all those things. So that's the stuff that you want. I don't know why 35. I guess there are at least 35 kids. I don't know, because the problem says so. So I want you to describe a number of jeans and hoodies that would be within your desired parameters. And I'm going to make up an arbitrary one. As long as it's within here, it's good. I'm going to choose one that's about right here. Now I'm going to make up that number is about 26, comma, you know what, I'm going to go a little higher up. I'm going to go with 26, comma, about 12. I'm going to say that point's about 26, comma, 12. See, that's not even on, that's not even directly like on a point. You know what I mean? How can you see this best, not make it look ugly? Anyway, 26, comma, 12. So what am I saying about that point? The fact that it's inside the shaded region? You can buy 26 jeans, pairs of jeans, jeans, and 12 hoodies. You see, 26 plus 12 is 38. That's more than 35. 26 times, I don't know if I'm going to do this whole thing, 26 times $20 per is $520. 30 times 12 is 360. Did I say 520? 520 plus 360 is $880. Whoo! I'm within budget there. I was really close to that 900 right there, but I'm within budget. That does work. If you bought 15 jeans and 25 hoodies, would you be within budget? 15 jeans, 25 hoodies. Is that within budget? No. No. This is above the budget. Here's your budget line. This is above the budget line there. It's in a shaded region, but it's in the shaded region of buying at least 35 articles of clothing. That's the wrong shaded region. Now, if I asked this, if you bought 15 and 15, would you be within budget? The answer is yes. But that doesn't state that you satisfied all the things you needed. Would it be a solution to the system? No. Would it be a solution to the budget inequality? Yes. But this one right here, the answer is no. You're not within budget, and it's not a solution to the thing because you're not within budget. So no there. Okay, and listen, guys, that's it. I say that's it, and I've gone for an hour. But that ought to do it for this one here. I hope that these things covered a large amount of things, and I sure hope it makes a lot of sense. That'll do it for this one. This is Mr. Robinson. Thank you so much for watching. I hope you enjoyed it, and take care. I will see you in the next one.